So basically, I kind of wanted to go through what it is we do, how it is we do it, all those kinds of things. First and foremost, this video is going to be on the dual feed 12 valve stuff with the big sack. And when I say big sack, if we look at the base of the nozzle, or actually the little nipple that sticks out for the sack, the base of that section is 1.5 millimeters. And the regular stuff that we use is 1.0 millimeters across, which is really close to like what a Bosch P570 would have been. Now, that's a great nozzle. It works awesome in 99.9% of everything on the planet. We use that nozzle in a blank for all of our ISB, so 98.5 to 2002. We use that nozzle in all of our first generation, so VE pump stuff. And we use that nozzle in the P7100 stuff, 94 to 98. We buy those things thousands at a time. We get them in here, they're complete blanks. So this is a blank 1.5 millimeter. There's no holes in this because we make the holes in this building. And then when we're done making the holes in this building, we can come here, we can measure the hole. Using this thing, we've got pin gauges in there, but when we use a pin gauge, depending on who's holding the pin gauge and who's holding the nozzle and how accurate they are, you can get this is what I'm going to market as a 12 thou hole. Now if I measure this exact hole, I get 11 thou 9/10. So if I roll it over just a little bit, I will find this dual feed also has pilots in it. And the accuracy, let's go right there. So I'm going to erase all my red dots. And we'll do that right up here. And then I'm going to go to this measurement again. I'm going to check that. And it dropped a round circle of dots again, which is an indicator that this hole is very, very, very round. Now, this hole is 12 thou 1/10. So whether it's the way the light is catching the hole, which that's probably what it is, but this thing measures at 2/10 of a thousandths different from the last hole. So we're going to market this as a 5x12 with the spray angle that I've chosen to use. We've modified and tweaked angles a little bit, so it's not a 155 like Bosch, it's not a 145 like Bosch. It's kind of Dynamite's secret sauce proprietary blend. So this is going to be our 5x12, but because the dual sacks have such a large sack diameter, inherently they're going to be a little bit, you can see my primary holes right there, and up this direction, which is closer to the piston, there's a smaller hole. And that smaller hole is going to make these things super cool because with pilot technology in there, let me see if I can get a better focus on that. Right about there. With pilot hole technology in on that, we're going to get better atomization than just what the large holes can offer. So the throttle response is going to be really, really, really good. And they're going to be a lot more drivable than just somebody's big dual feed nasty thing. And you're going to have a lot less black smoke, a lot better throttle response, everything about it, like cold start ability, drivability. We traditionally would not make anything in a big sack 5x12 because we can fit like a 5x18 in our P570 and that's good enough. But the reason why I wanted to try this little charcuterie board of nozzles is because I wanted to see what would happen with the big sacks and how undrivable they actually are in drivability. So as you can see that our pilot hole is 5 thou 7/10. So that was like 12 thou, that's 5 thou 7/10. So per our patent, that's about 50% of whatever primary hole size is. I'm going to leave all of the pilot holes that same size all the way up. This is a 5x12, this is a 5x14, 16, 18, 20, and a 22. So flow rates are something I'm going to show you here in just a second as well. We've got two different flow meters, and the reason we have two different flow meters is one flow meter is extremely accurate, clear up to 100 liters of air per minute, and then when you get to that, you have to, when the holes get to be so big, that you have to actually jump to, there's a larger ball in the other flow meter, and it requires more flow to get that ball to float. So although it's not a true 150, 160 liters per minute in comparison to the other flow meter, when you get so big, we have to jump it over, and we automatically just put the one in front of it. So you're going to see some nozzles that are 160 liters of air per minute indicate, and that's just that's a barometer. When we EDM them and then we extrude hone them or AFM them, at that point, we know for a fact that all of your nozzles are at least the exact same flow rate. So that was one end. That's the smallest I got. Then the biggest I got is going to be this guy right here. And these holes, again, were made in this building. Just to see if I can get my shaky hands to do that. That's perfect. So that's the size of my pilot hole in those little red dots. And that's the size of my primary on the big guy. So as you can see, the atomization of that small hole is going to be far better at low needle lift, low travel, and low pressure. So this was 5/7/10, that little round dot hole. I'm going to erase that. Now I'm going to go to measuring this. We're going to drop a line on this. Check it. That is 22 thou/3/10, and the out of roundness measured by this starlet is 0.0005. So that is an extremely round hole. Now, there's our pilot hole again. Let's see if I can put that in there just right. Oh God, it's so much work. That's a lot. But you can get the, so that's my primary hole size. That's my pilot hole size. And again, the pilots are just that much closer to the piston. So when the needle is lifting very, very lightly at idle positions, you're going to get a lot of flow out of those. But as soon as you start hammering down on the gas pedal, the needle starts to stroke further, and it's going to expose the big holes, and all the fluid, path of least resistance, is going to go through the big holes. So there's that. Now, let's walk you around the corner to air flowing. It's a small nozzle. This is 49 liters of air per minute. Now, that was our 5x12. And this is that big one. As you can see, the ball went straight to the top and maxed out the flow meter, so that would have to go over yonder. Now, this has a larger ball, still set at the same regulated air pressure. So we're looking at a 64. So this is something that we would call 164 liters of air per minute. So too big to be measured on this one, and this one still has plenty of room to grow. For some of the big tractors that we've done recently, it's maxed out this flow meter as well. Let's pick something in the middle of the road. So even 12, 14, 16, even the 5x18 maxes out the little flow meter. The 5x16 is 81 liters of air per minute. So going from a 5.16 to a 5.18, the difference was over 20 liters of air per minute on this flow meter. 5.16 is 81. Now, this nozzle is the maximum that I've seen any real good quality results with a single feed body. The single feed passage has so much volume available to it. When your nozzle is more efficient than your body, you need to add more body to it. So the next idea behind all that is injection rate. Like how fast can we shove that fluid through the injector body and the nozzle as a combined unit. So again, that's why I'm testing 12s, 14s, 16s, 18s. It's not because they haven't worked in the past for us for the last 20 years, they have. But with common rails and so much studying as we do on common rails, we're learning that the faster we can get the injection rate, the cleaner the power is and the more horsepower you can make per whatever inducer you've got. So it wouldn't surprise me to see this 5x14 outperform a 5x14 on the dyno with the single feed in a P570. I don't know that for a fact yet, but I'll know that here in like a week because we're going to start doing a bunch of dyno testing. Currently the blue truck, the transmission's not that happy. So on the dyno with that much load, we're going to have to fix transmission first before we can really get busy on dynoing it. But that truck seems to rip pretty good. All right, so now I want to show you another camera. Okay. Shameless plug. This is Hulk juice. I fell victim to it because they claim that you don't have to lift weights or eat any more calories. It's better than anabolic steroids. It's easier on your heart. It gives you energy. And they claim that it makes you look like the Incredible Hulk. It's my very first one. So we'll see at the end of the day if it worked or not. I called it Hulk juice because it was green. All right, so here's what I'm seeing right now. I am seeing 1, 2, 3, 4, 5 primaries at 12 thousandths of 1 inch. And we've got our 1 and our 2 pilots. And those were, what, 4.5, 5 thou were they? Off memory. Now this is our big boy. Let me get that camera just right. There we go. Okay, so much easier to see. This was extrude honed with extrude honed media for 30 seconds because I wanted to deburr all of those edges and clean them up. But that is a 1, a 2, a 3, a 4, and a 5 at like 24 thousandths of an inch. And again, my little tiny pilots are still in there. And they're in there just to enhance the atomization at low throttle positions. So this is a ginormous nozzle that in other ways of EDMing, I'm gonna say cut the camera for a minute. I'm gonna go find some junk parts just so I can show you in this video the EDM quality and the lack of extrude hone stuff. So give me just a minute to go find some parts and I'll be right back.
12 seconds later.
I found some parts. These are cool. I wanted to show you these. So back in the old day, before we had our own EDMs, all we had was extrude hone. So my thought was, is if I paid somebody to contract an EDM for me, I'd bring the parts back in, I would extrude hone them, and I'd be better than everybody else was. Well, this was the quality of EDM work that I got. Now, you can see there's massive piles of slag everywhere. The holes are starting to intersect. Where the pin, where the wire came across, it was at an angle and it came up and it tagged right there, and then it would form a crack right here, and the crack would drop all the way down and split the nozzle open. So the flow of this thing with fluid was horrible. Look at that. So just because you're buying a 5x18 or a 5x20 or a 5x whatever, because of really low quality work, you're not necessarily getting any atomization, and a lack of atomization means you're going to get a lack of proper burn, and you're not going to make the power that you think just because your hole size is what you're bragging about. So that was an EDM part, 5x18. Just for giggles, we're going to take this over to the scope and we'll measure it. Now this was something that I had drilled. Again, this is a nozzle that says 5x24 on it. This was done with an end mill. So they would chuck these up in a mill, and they would go in there at 20 or 40,000 RPM, and the holes are a lot cleaner. But because this is a P570 sack, there wasn't enough real estate in here to give me any shrouding. So the first thing is there's a danger of physically blowing the tip clean off of this thing. And the second thing is this and this, there's no shrouding around any of the holes. A lack of shrouding causes you a blowtorch effect. So the fuel, instead of breaking down into molecules small enough to burn, the fuel leaves there in a gross massive quantity, and it turns into a liquid. It never actually, or it stays a liquid form. It never atomizes well enough. It hits the piston and it burns its way right through a piston. So this supposedly is a 5x24. We'll go measure that in a second. And just for giggles, you can see there's sharp streams of fluid that are just coming straight out, and they're punching that bowl. That's the same thing that's doing to your piston. So it's a lot of quantity, but if you can't get the quantity to burn, it's not going to make any power. So that supposedly is a 5x24. Here's that 5x18. Again, I lifted the bowl. You don't see any wafting. Wafting would be good because then you would actually know that some of it was atomizing, but they're all such large droplets that nothing's really going to burn. Now this big nozzle, why would a smaller hole make better power? Well, because kind of wafts up. I don't know if you can see it on camera. There's kind of a cloud of stuff that's trying to get out of there. And that cloud is something you want to see, because once you add injection pressure behind that, you're going to get really good atomization, and it's going to do what it's supposed to do. So that's the littlest one. I say little, but it's still a huge sack. And I'm very curious to see what happens when we start doing dyno testing for same size holes in the big sack versus little sack, because I know the big sack has much better shrouding. And when I say shrouding, I mean like for like. 24, 22, 18. Eighteenth thou hole, 18th thou hole, 18th thou hole. But you see there's like a country mile between all the spray holes. That's good, because that means you're going to get equal flow going through 360 degrees of circular form through all those holes. That is what I mean by shrouding. So this is an 18th thou, and that's an 18th thou. So it's not just the hole size that matters. There's no shrouding between. They're all clustered together. That's just a horrible part altogether. And this was something that costs more from another brand than our stuff the way we do it. Okay, so now, whoop, come on back. Whoop. I'm going to clean this up with some brake clean. We're going to go see how out around these holes are. All right, guys, so this is that 5x24, and it's done with a mill, so it's, you know, pretty clean, pretty accurate. Now, I just tried to measure this, and it gave me about half the circle. Because it's so out of round, it won't grab the rest of the image. So I'm going to have to try and make this thing measure. No, it hates it. So this is it's not an accurate measurement, but it shows 27 thou 6/10, and you can see that those red dots are all over. So I'll measure one of the other holes and see if it's any more round. This one looks a lot better as far as a round shape. So we'll see what it measures out at. There we go. So you can see if I can get some really good focus on it. Probably as good as it's going to get. It's not bad. Our measurement there is 26 thou, 2/10. So big holes, they intersect in the middle, almost blew the tip off kind of a thing. There's our EDM nozzle done somewhere else. And supposedly this is an 18 thou hole. And you can see how horribly rough that hole is. We've got all that schlag and stuff out there. That's going to mess with the atomization of the spray orifice horribly. So let's measure this thing and see what we come up with. It's not going to lay a line on it. Oh boy. I'm not even going to get that to measure. So we'll try and change some light and see if I can maybe trick it into getting me a measurement. I don't think it will. It's gross. It hates this hole. So using this old school EDM process, the hole's so out around that there we go. It kind of measures at 20 and 20 thou 6/10. So by now I've showed you expensive tools that we should be using for today's fuel injection actively. I've showed you nozzles that were done by other places before we had our own tools. And I've showed you airflow metering. I've showed you how we measure hole diameter. I've showed you what it's like to actually grab a piece of the tungsten so you can accurately get a hole that you want. But the only thing that I haven't showed you is extrude hone and how that kind of process works. So what I will do is I will, just for fun, we already saw what the images of inside the nozzle look like previous to the extrude hone. And the extrude hone is something that I would traditionally do to clean up that stuff. So what I'm gonna do, just for a little added bonus treat, there's my milled one here. I can see it from a mile away. I'm gonna run the extrude hone on this, or the AFM. Hey Pat,
Yes, sir.
can you do me a favor real quick? Can you just run that, whatever you were doing, give me about 10 or 15 seconds worth of hit. It's a big hole, so it might not make, how much pressure you got it going to?
1800.
It probably will time out. It's probably gonna air out because it won't make like pressure, but cycle it for me a couple times, would you please? All right guys, so this is a good experiment because in the past, I tried to extrude hone those nozzles using this. This machine's not set up yet today because this machine's really good for what it does, but that one is hyper good and it's more accurate, and the AFM has a tendency to throw more K factor into the holes. So with the quality of hole that we can make with our EDM, the AFM is pretty much the best, up to about 15 thousandths of an inch. Anything bigger than that, like yesterday, I actually did extrude hone all those parts using the extrude hone, and I had to manually airflow check all of them using that. This thing has a flow meter built into it, so it's quite a bit more accurate, quite a bit more precise, and anything that's emissions related, the AFM is by far the better tool to use. So for 97% of our parts these days, AFM is what we're using. But I've never tried to AFM those old EDM'd out parts, so. Dankeschön.
Welcome.
So, I highly doubt that AFM cleared up any of the slag. It did not. So again, this ridge of steel is something that's going to mess up all of the atomization. So that's not great, and I didn't think that AFM would fix that. But just for giggles, let's go take a gander inside the nozzle and see if it's any better inside. Holy smokes. So that's the same nozzle that had all that slag inside of it. I am blown away at what a great job the AFM did at cleaning that up. Now you can still see that I've still got that tag mark, so it's still a junk part, and there's still some of the slag down in there, but it removed almost 100%. I mean, like probably 75% of that slag is now gone. It wasn't able to clean up down in that area right there, but it cleaned up the rest of it. So this part would be light years better than it used to be. I'm still never going to use it, but and there's still, back to the shrouding, you can see that all of the holes are smashed together, so there is no shrouding. But that was 15 seconds on an abrasive flow machine. That's how good all of these tools can be when you use them all in conjunction and let each tool do its own job. That's how good this stuff can be. So at any rate, a couple of experiments that we were able to show you. Needle valves. I think that's probably a conclusion. Oh, you know what we will show you? Dual feed body, meaning we've got alignment dowels for the intermediate plate and the nozzle. We've got one feed passage and a second feed passage, hence the term dual feed. Those were done in a factory based off a drawing and a blueprint. The intermediate plate was not something that we drilled out or milled out. That was something that we had ordered and built. And the mirror image to that nozzle is just that. So each one of these nozzles and bodies is a matched part to each other. So there we go, there we go. That is the assembly of a dual feed. So it's not fed by two lines. It's feeding the nozzle to try and keep the nozzle pressure as high as the line pressure with these really big style nozzles. So that is what a dual feed by definition actually is. All right, introduction video to dual feed 12 valve stuff. Lenny Reed, Dynamite Diesel Products. I am out. Have a great day.